right, guys, I'm going to bring you guys back for like 10 minutes. It's going to be super quick. I can't even speak. Super quick. All right, so I love just showing you guys this, okay? So if I asked you guys to find the derivative of 3x to the power 5 plus x squared in chapter 1, this would be your work. Potentially. Okay? So hence why does it make sense that they evolved and they figured out formulas to make it more efficient? Okay? Because now, guys, can we do that literally in one step? Yeah. Because the answer is 15x to the power 4 plus 2x. Do you guys see where that came from now, even from the first lesson we just did using the power rule? So the second lesson, why I do it with the first lesson, is if you have individual, what's the word? Terms, holy moly, right? If you have individual terms separated by a plus or a minus, you can just apply the power rule to each one of them, okay? So then you get to bypass all of that, and it's one step of work, okay? So that is what our sum and difference rule is, right? So the sum and difference rule just states, right, that if you have, okay, an equation where you have multiple terms separated by plus or minuses, you can find the derivative of each term. That's why it says d over dx, f of x, d over dx, g of x, just means find the derivative of each term, right? So you can use the power rule on every single term and then be done. So super fast and easy. So I'm just going to do a couple with you guys and then let you go. So just like lesson 1, there will be a few terms that you have to clean up a little bit before you can apply the power rule to each individual term. All right, so this one really quick would just be the derivative of f of x is 15x to the power of 4 plus 2x. Done. So here, a tiny bit of cleanup. So this one, I'm not doing the derivative yet, just because I need to get rid of that radical, just like we did before. So that'll be x to the power of 1/2. Now we can find the derivative. I should come to class on time. So again, our power rule just means, if you look at the first initial notes, how you get it is the exponent can come down in front, and then the exponent gets subtracted by 1. That's it. Okay, so then for this one, right, the 3 comes down, Nikita, to get a what? Perfect. And then x to the power of? 2. That's it. So then minus, so 6 times half is 3, and then if we subtract 1 from half, we're going to get negative half. So we cannot leave negative exponents. So then that would be the same as 15x squared minus 3 over x to the half. So with this, guys, I would accept that answer, okay? But will you guys be okay if they give you, so then, because they might get a common denominator. So if they give a common denominator, right, we have to times this by x to the half, which would be 5 over 2 minus 3 all over x to the half. I'm going to let that sit for a second, if you guys agree with me. Because do you guys agree that if I have to get a common denominator, I have to multiply the top by x to the half? Do you guys agree? So then what do we do to those exponents? We have to add them. Is this the same thing? I'm doing this term right here. I'm just dealing with, guys, all I'm doing is making sure that you can get a common denominator over the x to the 15x to the power of 2.
Yes.
So if I needed a common denominator, I would need to multiply the top and bottom of the 15x squared over 1 by x to the half. So I'm just that over here. This right here is just dealing with dealing with my 15x to the power of 2 term. So are we okay with this? 15x to the 5 over 2 minus 3 all over x squared. And again, it's not something that I'm okay with you guys stopping here at this level. But if the answer key, right, because you guys will have lots of answer keys to look at. If the answer key does this, I need you guys to be okay that they just got a common denominator and it's equivalent. Okay, which is also, so you guys will see I do lots of equivalencies. Did I do this in Math 30-1 with you guys too? That's why lots of you did really well in your diploma. Right? Is because you guys don't know where they'll stop. So you have to be okay with all the different levels. Okay? So then this would also be the same as 15 x to the power of 5 minus 3 all over square root x. Is there one other thing I can do? Take the what downs? I don't know what you're saying. Oh, so you're saying rationalize? Mm-hmm. So you could do that. This is what I was thinking. I'm going to do that as well. So this is the same thing. Is that the same thing? I'm going to deal with what you said too, but that they for sure would simplify that x to the power of 5 underneath. Because x to the power of 5 is the same as x to the power of 4 times x. X to the power of 4 comes out as x to the power of 2. So that's a simplifying step that you would need to do, okay, if it's in radical form. So then this then is the same as, so if you now rationalized, it would be 15x to the power of 3 minus 3 root x all over x. I'll explain that. So, pardon? So would you, pardon? Talk to me. Do you have a question? No. All right. So from here, because and the thing is in calculus, guys, I'm okay with you leaving a radical in the bottom. We don't have to rationalize, okay? But if you did, are we okay that 15x squared root x minus 3 all over root x, if we rationalize, we'd have to multiply the top and bottom by root x. So then that would give you 15x squared, root x times root x is just a what? X. So then I have another one. So I've added it on to my 2 that were already there. And then I still have to multiply it by the minus 3, which would be a minus 3 root x all over x. Right? So that's all your pre-calc to break that down. Well, you can, but that to me is not a simplifying step. If there was a 9 on the bottom, absolutely you would have to. So that's what you're talking about, take out a 3. So you could, but again, this one technically you wouldn't have to do, but only reason that you would have to do this is if pretend we had a 9x on the bottom, then this step would have to get done. Try that again. Erase. So then 5x cubed minus root x all over x. So this step technically doesn't have to be done in this case because it doesn't help us simplify anything with the bottom, but absolutely this is also equivalent. Okay. So again, we did lots of steps of simplifying, okay, that again, at your university college level, they might expect you to go all the way down to this, right? And you guys have the skills to do it. Okay. Yep, there's not a skill there that we haven't learned before, right? Is that all pre-calc, guys, that I just did there? Everything, that was all grade 10 and 11. And 12, oh no, grade 10 and 11 was all that. All right. So this little guy here, Right, we need to clean it up a tiny bit, so this would be the same as y equals x to the negative 2 plus 5. So then my derivative, so I bring down the negative 2. So I have negative 2x to the exponent of negative 3. And what is the derivative of a 5? 0. So again, not that you have to write 0, but I'm just putting that in the notes to see what happened to the 5. Right? The slope of 5 is 0. That was another one thing we talked about at the beginning of class. Yeah. Think about what this is. This is the slope function. Y equals 5 is a horizontal line. So, and if you think about it this way, if you bring the 0 down, 5 times 0 is 0. Or is that not okay? Where's the one? What? Why are you saying 1? Guys, so technically, guys, if you want algebra behind this, technically, is this the same thing? 5 times 0 is what? 0. So 0 minus 1 is negative 1, but 0 times x to the negative 1 is still 0. What's 0 times 5? 0 times x to the...
Oh, because it's 0 from there.
Yeah. This is the same as 0x to the negative 1.
But do you not take the, because 5 is like 5 to the 1, would you not take the 1 times 5?
No. You're taking the derivative. You're not evaluating that. So, yes, I agree. But you're doing your slope function, guys. I don't know what you're confused with. So, okay, I'm going to do this again. Pay attention. I'm going to show you guys 2 different ways. So right now, think about, are we doing slope function? So open your brains really quickly. Y equals 5. Do you guys all agree is a horizontal line?
Yes.
What is the slope of, because the derivative function is your slope function. What's the slope of a horizontal line?
0.
Hence, this is our derivative function. So the slope function of y equals 5 is 0. You wanted to do algebra behind it. So if we do algebra behind it, then you're looking at this, using the actual power rule. So if you're using the power rule, then you have to picture it like this. Right? Because if you say x to the power of 0 is 1, are we back to the original equation? Yeah, so then you have to go back to what's the slope of a horizontal line. Okay? So if you don't want to think about it that way, then you have to think about it this way. My derivative function now, use your rules. What happens to the negative 2? It comes to the front. And then what do we do to the exponent? We subtract 1, which gets me negative 3. Plus, what does the exponent do? It comes to the front. 5 times 0 is 0. X, 0 minus 1 is negative 1. 0 times x to the negative 1 is 0. That's what I was saying the whole time. But I did. I'm pretty sure I did. You needed the visual, I guess. Okay? So again, do you need to do that with the constant? Put an x to the power of 0 on it? No, you should be thinking. A constant is a horizontal line. What's the slope of a horizontal line? 0. Hence, so remember, that's just your slope function. So guys, I'm just showing you quickly again. Oh, I went too far. So did we talk about this already at the beginning of the lesson? So this little guy here, did we talk about the constant rule? Right, the constant rule means if you take the derivative function of a constant, it will equal 0 because it's a horizontal line and the slope of a horizontal line is 0. All right. So I'm going to do D with you guys, and then you guys are going to try to figure out example 2. And then I will go over it with you after. All right, so for this one, I'll move this stuff in a second. I'll do this over here. So we have to clean this up a little bit. So we have y equals x. So we already did this one, but this type of one. So no derivative yet, because right now we have product rule in the front, and we don't have a product rule that we know yet. So we do have to break that down, just like we did last lesson. So this is going to be x to the power of, perfect, 3 over 2 plus 5x squared. So now my derivative is 3 over 2 x, so minus 2 over 2, which will be 1 over 2 plus 5, plus 10 x. So that is good. Right, or we can say 3 over 2 root x plus 10x. So now what you guys are going to do, so example 2 just says find the equations of the line or lines passing through a point and tangent to the curve y equals x squared. So is this a little bit different than what you're used to? So problem solve it, and we'll talk about it in 10 minutes. Pardon? No.